Okay, so today we're doing section 1-2, and it has to do with measuring and constructing segments. So over here, oh man, did yours do this too? Or just mine? I don't know why when I take this, it's a file, when I send it to the computer or the printer, sometimes it does this. I have no idea why. It should be connected. The points on a line can be matched 1-to-1 with real numbers. Like, I don't know why that space is there. I apologize. So here's a picture. Here's 2 points on the line. We named those points A and B. We can match those up with numbers. So right now it's x1, x2, but it could be 5 and 7 or 12 and 32. It can just be matched with any numbers, you know, on the coordinate plane or in a number line. And then the real number that corresponds to the point is the blank of the point. So the blank that goes in here is the coordinate of the point, coordinate. So when I use the word coordinate, we're just talking about that number that corresponds to the point. And the blank between points A and B, written as AB, is the absolute value of the difference of the coordinates of A and B. Woo! What I'm talking about here is the distance. So anytime we want to find the distance between A and B, this is important. This is important. This is a new symbol. Anytime we were talking about the distance between A and B, we write it as AB. How is that different than a segment AB or a line AB or a ray AB? How is this different? It doesn't have anything on top. If there's nothing on top, we're talking about the distance from A to B. So this is how we write a measurement. So it says it all in here, but I'm just rewriting to reinforce. AB is a measurement to A and B, from A to B. And to find that measurement, if it's in a straight line like this, we just take our x2, our second x, and we subtract our first x, and then we do the absolute value of the two of them. So absolute value just means it's always positive. Well, that's not what it means, but for us, it's going to make it always positive. So this is the distance formula. A couple additional notes. If we have a rule that's accepted without proving it, we can call it a postulate or an axiom. And then a rule that can be proven is called a theorem. So if we can prove something, it becomes a theorem. If we just accept that it's true, it's called a postulate. And then you can add those to your vocabulary packet later. Next vocabulary word we're going to use so much in this geometry class, is congruent. 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 Have you guys done congruent before? Maybe not sure. Okay, so congruent would be, congruent segments would be line segments that have the same length. Line segments that have the same length are called congruent segments. So if first you measure them and you find that the two line segments are equal, this symbol right here means equal to. You can say, well, if they're equal, then they are congruent. This symbol here, I'll make it even bigger, means congruent. It's an equal sign with a little fancy squiggle above it. This means congruent. Congruent is the same size, same shape, same length. Okay? Equal sign means equal to. Equal sign with a fancy thing above it means congruent to. I want you to look at the symbols with AB for these two examples. For here, what does AB have above it? The silence means nothing, right? CD has nothing above it. And guess what? Equal sign, nothing above it. But over here, when we talk about the segment itself, and we're not talking about the numbers, we're talking about the segment itself, and we say segment AB, is congruent to segment CD. The segments have stuff above them, and so does the equal sign, because it means congruent. So those are two different ways of writing. Well, it's like different information that we're writing. This one's equal, meaning numbers. And then this one's equal, meaning the segments are congruent, not equal. Did I tell you? I'm pretty sure I told you the first day. Geometry is like learning a new language because we have to learn like all these different symbols and vocabulary words. Okay, the segment addition postulate. See, this one right here says postulate. That means it is not proven, but like we just accept that it is true. Okay? The segment addition postulate says if we have point B that is in between point A and C, we can take the segment distance from A to B. We can add on the segment distance from B to C, and we will get the segment distance from A to C. All right, real fast example here. Somebody give me a distance for A to C. Yell something out. A to C is? Give me a number. 11, thanks. Somebody yell out something for C to B. 5, okay, thanks. So the segment addition postulate says AC plus CB equals AB. That says if I take 11 plus 5